Let's do some calculations. These are the equations for calculating the pitch perceived by an observer, which is pronounced as F prime, when the source of sound is moving away from the observer or towards the observer. The capital V's in the equations refer to the wave's speed, and the lowercase v's to the speed of the source of sound, the object which is emitting the sound. A train that is moving at 12 meters per second approaches a level crossing. It warns some pedestrians who are stationary at the crossing by sounding a siren at a frequency of 1050 Hz. Calculate the frequency heard by the pedestrians, A, as the train approaches the crossing, and B, as the train passes the crossing. For the first part of the question, the wave-emitting object, the train, is moving towards the observer. Therefore, the equation in which the emitter's speed is subtracted from the wave's speed is used. The pitch observed by the observers is the unknown value, f prime. Since the question refers to sound waves that are traveling through air, one would have to look up the speed of sound in air, and one would find that that is 330 meters per second, and that is used as the value of capital V here. The speed of the train relative to the observers is 12 meters per second, which we substitute into the areas of small v's. Substitution into the equation yields the observed frequency to be higher than it really is, namely 1089,62 Hz, which makes sense, since when a sound-emitting object approaches an observer, the waves seem to bunch up, increasing frequency, therefore pitch. For the second part of the question, the wave-emitting object, the train, is moving away from the observer. Therefore, the equation in which the two speeds are added is used. The pitch observed by the observer, f prime, is the unknown value in this question too. Since the question refers to sound waves that are traveling through air, we again use the value of 330 meters per second, substituting this into the large V's, the capital V's, in the equation. The speed of the train relative to the observer is again 12 meters per second. Substitution into the equation yields the observed frequency to be lower than it really is, namely 1013,16 Hz. This makes sense, since when a sound-emitting object moves away from an observer, the waves seem to spread apart, decreasing frequency, therefore pitch.